Hello everyone, my name is Johanna and I will be introducing you to the Tremor Freetype keyboard app. The Tremor Freetype keyboard concept was designed this summer by our team of 4 students, Taha, Cesar, Jonathan, and me, as a part of the Case Western Biomedical Engineering Alliance Design Challenge. For individuals with hand tremors, use of computers is a persistent challenge, and most computer operation advancements are not developed with individuals affected by hand impairments in mind. Consequently, the widespread use of these devices for the completion of daily activities is an ever-growing barrier to accessibility for these individuals. Research shows that an estimated 2.2% of the U.S. population is affected by tremors, and surveys show that there is an estimated 15% difference between whether disabled and non-disabled people own or use tech devices like desktop computers, laptops, and tablets, including across age groups and accounting for reduced tech use in older populations. We are able to observe that there are glaring barriers for individuals to access computers because of design features that are contingent upon precise and controlled translational motion of the hand and fingers. While voice control has helped solve this, not all computers are equipped with such software, and the environments it can be used in are limited. People with tremors also experience difficulty using traditional keyboards without frequent errors, as well as conventional mouses and trackpads because of unintentional motion and clicks. Our solution is to develop a swiping keyboard application modified specifically for individuals with tremors. Our concept is called Tremor Freetype. It is a Tremor Filtering Continuous input keyboard app characterized by a swiping movement of a single digit on a trackpad or tablet screen to spell, instead of the traditional typing motion of multiple digits. The concept of general swiping keyboards is not a new one, but our design modifies these algorithms to reduce the noise created by involuntary muscle movements of people with tremors to still allow for accurate detection of the words the individual is attempting to spell. Our design has 3 stages of development. The first stage focuses on the accelerometer and gyroscope that detect the 3 axes and collect their respective data. With this data, the algorithm will detect whether the subject is experiencing a tremor and document axial changes created by the shaking motion. The algorithm will then store this data accumulated by the sensors, which is then filtered to assess the user's intended motion. With the incorporation of machine learning, our algorithm becomes self-learning and sustainable as more data is collected while the user experiences tremors. The second stage is filtering. We will integrate a low-pass filtering technique to reduce the noise created by the shaking of the swiping digit, which allows the algorithm to more accurately interpret the user's intended swiping path while they're experiencing a tremor. The outcome is a smooth path that more closely resembles the user's target path, which then becomes the input that is used to assess the word the user is attempting to spell. The third stage is the output specifications. The algorithm uses the filtered data to assess the intended path of the swiping input, and then outputs the intended word to the user. Incorporating machine learning, the algorithm will also constantly adapt to the user's benefit by modifying the dictionary of words, the size of keys, and the swipe path precision. As a result, Tremor Freetype allows for faster inputs for users with tremors, as the swiping motion only requires the use of a single digit and only one type of translational motion. So why our solution? Tremor Freetype allows people experiencing tremors to have a normal typing experience. It helps to eliminate a few of the ever-expanding list of barriers to computer use for individuals with tremors, and provides an avenue for more individuals with hand impairments to be confident in their ability to quickly and efficiently operate a computer. The user interface is intended to be very intuitive and allow for a smooth typing experience. It will be suited for both laptops and touchscreen devices. To market our application, we will highlight that Tremor Freetype is not for profit and open source. This means that it will come at no cost and the source code can be shared by our users. Even though our interface will be designed with ease in mind, a detailed user guide will be sent upon application download. An integrated social media strategy using Facebook, YouTube, and Instagram will focus on reaching individuals with tremors and will provide tips for better use of the app and news about novel app features. Thank you for listening to our pitch. Be sure to like, subscribe, and share this video.